Welcome all of you to this video of Maths Made Easy. As I told in my previous video, I shall be taking up pressure in fluids here in this video. So it is connected to pressure only, little different. So let us see what it is. Firstly, let us understand the meaning of fluids. What is fluids? Okay. So fluids is not liquids. Okay, you might be thinking it is liquids. Fluids is not only liquids. Anything that flows is a fluid. Okay, so gases are also fluids. Okay, so anything that can flow is a fluid in physics. So here we'll combine, here we'll take liquids and gases, we'll assume it to be so. Okay, what exactly is the pressure in fluids? So let's see how we calculate. Before this we had pressure is equal to thrust by area. Now what happens? Okay, supposing we have a cylindrical vessel, so supposing we have a cylinder here, okay, and it has water filled in till here. This is the water. Water is filled in to a height h. Water is filled in to a height h. Okay. Now whatever water or whatever liquid, kerosene, petrol, diesel, whatever it is, whichever liquid it is, the density is rho. Let's take the density as rho. Now we are going to find the pressure over here at the base of the vessel. At any point on the base of the vessel, how much is the pressure? Now what is the force acting on it? The entire weight of the water is acting. So same formula only we are going to use. Okay, what is the weight of water? Now remember, for now area of this base, we'll take it as A. We are not given radius, we'll take it as A, area of the base. Now we know that volume of anything, okay, volume of any regular solid is area into height. Yes, so area into height. Why am I writing volume here? Okay, we have to understand this, that density is mass per unit volume. Means this is an old formula. Density is mass per unit volume. Mass is density into volume. So here I am trying to get mass of this liquid. So this is volume into density. Okay, that gave me mass into G, because I want mg, right? If I want the weight of this water here, this liquid here, I want mg. This much is mass, this is G, mg. So that gave me the weight by the A. The area of the base. Okay. Now, how much is the pressure? See. So this is the pressure. What is it? Height of the level of water, vertical height, into rho, density of whatever liquid it is, into G, acceleration due to gravity. That gives us the pressure. So we say this is pressure of fluids, the formula of pressure of fluids. So this is how exactly we got it, that I told you. Okay. Now there are some examples based on this too. Now, why are the base of dams made wider? Is a very commonly asked question. Why are dams made wider at the base? Okay, why are dams made wider at the base? Okay, dams, that is dams or rivers. Now this is a dam. Okay, and you will see that one side is sloping like this and the other side is, okay, so this part they are saying, why is it made, slowly you see it is broader here. This is the part where you have the gates, and this part they made little broad. Why always? Why is it made broad? Now this is the side which is having the water. Okay, the river water is here. Here you have a huge collection of water. The dam has stopped the water here and now letting out water in a controlled way. Okay, so here maybe they are using it for irrigation, whatever, hydroelectricity, whatever they are using it this side they are letting out water in a controlled way. So they need to hold that much of water. Now why this is broad? Because actually if we see down here, there is a tremendous pressure of water. And remember, pressure, okay, if I have water here, just now I was talking about the cylinder, I forgot to mention, here pressure, okay, pressure here or here, wherever, remember it does not work only downwards. If I say pressure at this point is 10 Pascal, it means 10 Pascal is working this side, it is working on all sides. Okay, so pressure is working on all sides. So here pressure is not only working down, but it is also working like this on the walls of the dam. So this part of the dam is under a tremendous pressure because of this huge collection of water. Now what? If you don't make it wide, if you don't make it strong enough, when the water collection is very high, this pressure is very high, this dam is going to crack over here, it is going to break, the whole dam is going to collapse. So lower we go, wider it is made. That is the design, to withhold, to take the pressure of so much of water here. So this is the meaning of, okay, why are dams made wider at the base. What will you write in the answer? You'll have to write that pressure acts on all sides and pressure increases with depth. Okay, so you have to write pressure acts on all sides at a point and pressure increases with depth. So the lower we go, the water pressure increases. So it has to be made nice, wide and strong. That's why it is made like that. Made wider at the base. Okay, let's see some more examples. Suit, diver's suit. What is a diver's suit? Okay, diver's suit is when people go for this scuba diving, or they go for all these other they go under the water. Now under the water they don't go for a few meters, they sometimes go very very deep inside the water, and when they go this deep inside the ocean, remember, if they are going very deep into the ocean, there's a whole column of water on them which is putting pressure on them. So their suits are specially designed to withstand all this pressure of the water above them. Okay, so what is happening? So their suits can take the pressure, so it does not allow the suit takes all the pressure, and that helps them from breaking the bones. The bones don't break because of this. Okay, so they don't break the bones because of this suit. Okay, so if they have to dive, these divers have to put on these suits. So you have to tell what is the keyword. What is the keyword here? You have to tell the deeper they go into the water, the more the column of water above them, so higher the pressure. So they have to put on specially designed suits which can take all this pressure, and these people don't break their bones. Size of gas bubble inside water. Okay, size of gas bubble inside water. Now, size of gas bubble inside water, this is, you might have seen this in aquariums, that there'll be some machine which is constantly leaving out some gases, leaving out oxygen into the water, and if you see at the bottom of the aquarium, size of the bubble is this, slowly becomes this, slowly becomes this and this. So by the time it goes up in the water, the size of the bubble increases. This is because size of gas bubble increases inside water. Why does it increase inside water? Because here, if you see, if the water is filled till here in the aquarium, okay, here pressure is higher. Pressure reduces. So the gas inside the bubble expands. Pressure further reduces as it goes up. That is why the gas expands, the bubble expands. Okay. Now let's go to another question, which is very interesting question. You might have seen it in sometimes. Why do seawater fishes sometimes burst when taken out of deep sea water fishes burst? Okay. Why do deep sea water fishes burst when taken out? When taken out. This is a very common question. Why do deep sea water fishes burst when they taken out? Now, why do they burst? Why do they burst? Okay, fishes. Now, deep sea, actually in the sea also, you should know that different types of fishes are found in different depths of water in the sea. Okay, so when deep sea water fishes, they are these boats go and they fish, they do this fishing in deep sea waters, and they go maybe few fishes which they have picked up from a very big depth. Now that fish, the body of that fish is designed and to withstand a lot of pressure. So withstand a lot of pressure underwater. Okay, it generally is made to withstand this amount of pressure underwater. Now what happens? Okay, when it is brought out, the entire pressure is gone. Okay, so the blood vessels are designed to take so much of pressure. Now what happens when it is taken out? When it is taken out into the open, there is no pressure above it, but the blood inside the vessels are still moving at a very high pressure to withstand this. Okay, to withstand this kind of pressure. So what happens now? Their vessels burst. Their vessels burst, and that is why they are saying they burst when taken out, because over here when they're taken out of water, the blood vessels burst and they die due to, not just due to lack of oxygen, but they die because their blood vessels burst. That is also another reason. So these were some of the important give reasons for pressure in fluids. Okay, so we have some nice numericals on pressure in fluids. We'll do it in another video. Till then, keep following. If you haven't subscribed, subscribe it and keep watch on the playlist. I shall be uploading many more videos very soon. Okay, for the whole of 9th standard syllabus. Okay, bye then.